So welcome again to the Science 2022 paper 2 as we continue with question number B7. It says many carbonates decompose to form the metal oxide and carbon dioxide. Table 7.1 shows the mass of the carbonate before and after heating. So this is what they have showed us, the carbonate and their masses before and after. Then it says, so it's important to study that diagram properly. Write a balanced chemical equation for the decomposition of zinc carbonate. At least they gave us an idea there. So write a chemical. So zinc carbonate, that in solid form, when it actually decomposes, it forms a metal oxide, which is zinc oxide in solid form. Then it also produces, carbon dioxide, which is a gas. And if you look at it, is it balanced? There are 3 oxygen, 1 plus 2, that's 3 also. Well, there's 1 carbon, 1 zinc, 1 zinc. So it's already, self-balance. This is actually self-balance, so you don't need to balance it up. B says, which carbonate is the most thermally stable? Give a reason for your answer. So which one is actually thermally stable? So if you look at it, the masses before and after, so you look at which one has actually changed much. So which one is thermally stable? I can see number 5, before it was 2 gram, even after it was actually 2 gram, meaning that there was no what? There was actually no change in this case. So I would go for, potassium carbonate. It is actually the more stable one. Potassium, carbonate is more thermally stable. Now, why are we saying that, potassium carbonate is thermally stable? Yeah, the reason, if you look at the mass, so we can simply say its mass, does not change upon heating. So the mass has not changed upon heating, indicating that it is thermally stable. Then C says calcium oxide is produced on a large scale by heating calcium carbonate in a kiln. What environmental problem is associated with large-scale production of calcium oxide? So when calcium oxide is being produced, there's a gas that is actually given out, which is carbon dioxide. So this process releases carbon dioxide, and carbon dioxide is simply a greenhouse gas that causes or contributes to global warming. So I can simply say the effect, it releases CO2, that's carbon dioxide. Please, you can write that. So it releases carbon dioxide, a greenhouse gas that contributes to global warming. So it produces a carbon dioxide, a greenhouse gas, and that helps to contribute to the raising of temperatures on the Earth's surface, where polar ice caps that have never melted will melt, flooding low land areas. Then this says select the carbonate which on heating produces a compound which is used as a refractory material. Now if you look at the word refractory, a refractory material is simply a material that is capable of withstanding very high temperatures. Yeah, and in most cases, such materials can be used in lining of, kilns, what we call as being incinerators. You can actually use them in incinerators. You can actually use them in, reactors, such as even in the blast furnace. You can also use them in furnaces. So it's possible you can use materials that we call as being refractory materials. So they are able to withstand very high temperatures. And a very good example among them there is actually, magnesium carbonate. Because when magnesium carbonate, breaks down, it produces magnesium oxide. So magnesium oxide is actually a refractory material. So select the carbonate. So it is actually magnesium carbonate. So magnesium carbonate. So when magnesium carbonate is decomposed, it produces magnesium oxide. So it's this magnesium oxide. In most cases, refractory materials, most of these ionic compounds can be used as refractory materials, but magnesium is actually very good. Right, hopefully that gave you some ideas. You are able to answer questions in the exam. Let's move on and try to look at B8 there. So if you look at B8 there, it says 3 gases A, B, and C have properties shown in the table. So there's a density, solubility, and appearance. So let me give you some idea. When it comes to gases, let me say collection of gases. If you want to know the method of collecting, let me say method of collecting a gas. The method of collecting a gas depends on 2 things. One, we look at solubility, its ability to dissolve. Is it able to dissolve in water or not? So the solubility. Then we also focus on the density. So these are the 2 properties that we use to determine the method of collecting a particular gas, and hence you need to remember. So if you look at the density, solubility, and appearance, so gas A more denser than air, soluble, colorless. B less denser than air, soluble, colorless. Gas C more denser than air, then insoluble and colorless. So some apparatus used to collect gases are shown in the following diagram. So mainly these are ways of collecting the gas. The 2 of them, X and Y, are simply called, we simply call them as being displacement. Such method are called displacement of air because both of them use the fact that they are displacing air. But if you notice, the gas that is being collected is taken to the bottom. Sometimes it's known as being downward. We call it as being downward delivery. And in most cases, you can use this displacement of air, the downward delivery of the gas, mainly for the gases such as hydrogen chloride and also carbon dioxide. They can actually be collected like that. I'm giving you an idea so that even when you study, you find the question, you'll be able to answer it. Then, of course, even this one is still displacement of air, but because the gas you are collecting is being taken up, we simply call it as being up. We can call it as being upward delivery. So because you are delivering the gas upward. And most cases, gases of that nature that can be delivered, gases like hydrogen. We can also talk about ammonia. They can actually be collected. Now, when can we use the downward delivery? For what type of gases do we use the downward delivery? So the downward delivery is used in terms of gases that are denser. So for those gases that are denser than air, so if the gas is denser than air, then downward delivery is okay. Then here, for gases that are less denser than air, so if the gases are less denser than air like hydrogen and ammonia, then you can use the what we are calling as being upward delivery. Remember, this is downward delivery. I hope that is helping you. Then for this one, the method is simply called as being displacement of water, because what you are displacing when the gas enters, it will be, in most cases, it will be water. This method can also be used in collecting ammonia, but in place of water, we don't use water. They use a dehydrating agent like calcium oxide when you are collecting ammonia. So take note of that. But this method is called displacement of water. Where is the water being taken? Downward. So it's a downward displacement of water, so that the gas can be collected. For the gas to be collected there, it has to push the water down. So if you want, you can simply call it as being downward, and you say displacement of water. And in most cases, this method is actually used for gases that are insoluble. So for those gases that are insoluble in water, so if the gas is not able to dissolve in water, this is the best method. Gases like hydrogen and oxygen are best collected using this method. So now notice which apparatus X, Y, or Z is most suitable for to collect gas A. So for gas A, they told us it is more denser than air, but it is soluble. So if it is soluble, you can't use this method. It's just between these two. But because it is more denser than air, it has to go to the bottom. So you can simply use, so it says which apparatus. So we can simply use apparatus X. Then B, it is less dense than air. Because it is less dense than air, meaning it will be collected upward, it will be delivered upward. So I can simply say apparatus, Y. I hope it's making sense with what I've actually given you there. Right, let's move on and see, what we can do there. B says gas C can be collected using apparatus Z. State why apparatus Z is more suitable than apparatus Y to collect gas C. The reason is that one, it is actually more denser than air, but more important, it is because the gas is insoluble in water. It cannot dissolve in water. So the gas is insoluble. So I can simply say the gas is insoluble in water. Hence, Z, or we can say apparatus, Z is, suitable. So that's what you could have said there. 2, state why apparatus Y is more suitable than apparatus Z to collect gas B. Yeah, why is it? It's because, again, of the solubility. It is less dense than air, then it is actually soluble. So we can simply say that the gas, or if you want, you can say gas B is soluble in water and less, denser than air. So it is actually more suitable to use, Y, apparatus Y, as compared to Z, because it is soluble, it will dissolve, so we don't want it to dissolve in water. C, suggest the name of the gas that would be collected using apparatus X. So what is the name? Remember what I told you, I gave you examples. So please, if you're not familiar, just go back on this one. So the gas that could have been collected could either be carbon dioxide. So you can either collect, carbon dioxide, CO2, or you can simply collect this gas, hydrogen, chloride. So you could have actually collected, such gases. It is very much possible. Hopefully we are together. Let's conclude with B9. It says the following diagram shows some of the reactions of ethanol. So if you have done organic chemistry, well and good. This is under organic chemistry, and organic chemistry is very beautiful. Please look out for some of my videos in the chemistry playlist, then you'll be able to at least learn if you have not done this. So ethanol can undergo oxidation, meaning it combines with oxygen to produce solution P. Normally when alcohols undergo oxidation or using an oxidizing agent, they form up carboxylic acid. But because this is ethanol, that should be ethanoic acid. That's the name of the carboxylic acid. Ethanol, when undergoes process Q, can produce ethene in this case. Now for that to be produced, this is what we simply call as being dehydration. So when you remove water from the ethanol, it will produce ethene in this case. And when ethanol undergoes complete combustion, it produces carbon dioxide and water, and that's what they wanted you to do there. Then it says draw the structural formula of ethene. Now ethene, the number of carbon atoms is 2, the general formula is Cn then H2n. So when n is 2, it will be C2, then 2 times 2 give you 4. So now remember, these guys that belong to this homologous series, they have a double bond. So there are 2 carbon, but there's a double bond between the 2. Then you can attach the hydrogen. Remember, when you're writing, carbon is tetravalent, meaning it forms 4 bonds. So here you had 2, so this carbon needs 4 bonds. You had already 2, so you just needed 2. 1 2 3 4, 1 2 3 4. So that is what we do. Carbon is tetravalent, and that's what you need to remember. Then it says B, give the names of solution P. Solution P, like I said, that is ethanoic acid. It is a carboxylic acid process. Q is simply dehydration. So you need to remove water, and there are conditions that are there. You can use a dehydrating agent like concentrated sulfuric acid. And gas R is simply carbon dioxide. So it is actually CO2. Write a balanced chemical equation for the complete combustion of ethanol. So ethanol is C2H5OH. When it undergoes with oxygen, it produces carbon dioxide plus H2O. So we just need to now try to balance up, this equation and see if it is actually, balancing there. So that's what you need to do. Now, if you are to balance up this one, we can put up a 3 there, and we can actually put up a 2 there, and that would be a 3 there. Then this is actually going to balance because there are 2 carbons. That's why I've put up a 2 there. If you notice, the total number of hydrogen is 5, and plus 1, that's 6. That's why I've put up a 3 here. 2 times that is a 3. Then the total number of oxygen, that is 6, plus this, that's 7. If you notice, 2 times 2, that's 4. Then here there's 3, so that's 7. So meaning that it is actually balanced. So this is what you needed to do. Please watch out for my other videos and try to see. I'll be able to do some of the questions in this section, then you'll be able to to see them. Thank you so much for watching. If you love what we do, please you can subscribe to our channel, then you continue to see more of these videos.